Okay, hello guys. In this video, we are going to create a hexagonal tiling, such as this. Or, for sake of simplicity, we start creating with this. Okay, let's make a new layer, and I will put down a six-sided flat disk, just like that, on the y-axis, and let's copy this and paste it to a next empty layer, and let's figure out how should we move it so we can form this pattern. As you see, if I do it by hand, it's not really successful, so let's undo this. But we know that this translation happens along this vector, such as this layout, this diagram shows. Okay, this vector is defined by these two subvectors, and they can be computed either using these formulas, or just simply selecting these points, bring up a point info panel, and then you will see the two coordinates, and if you subtract from point 2 coordinate x, point 1 coordinate x, then you will have this amount of translation, and the z component of point 2 will give you the exact amount you have to move upward this fractional number. Okay, I would rather go the other way, the trigonometry way, because if you learn this, then you will learn a bit of math and trigonometry and etc, and it comes handy later when you are dealing with vectors and math, maybe MoGraph, or you go into Unity or other applications such as Houdini. This knowledge is always useful and beneficial, so I think this is the proper way to do it. Okay, the x coordinate is easy to calculate. We just bring up the calculator and we substitute r with 500, because r in this case is the radius of the hexagon, and also every side has the length of 500, because the nature of regular hexagons is such that every radius and all sides are equal. So 500 by 1.5 is 750. So we go over to this newly created mesh, press T and N, reset, and I just type 750, and the other value is 60, the sine of 60 multiplied by 500. Copy the first 4 digits of the fractional part, copy, and paste it here. Apply. Ctrl X, go to layer 1, Ctrl V. Okay, voila, we have the first pair. Now the only thing to do is to multiply it and create an array. As you see, it's already been set up, but I just for sake of this tutorial I reset it, because for some strange reason, if I reset, now it has been reset to the previous state. It's very strange and stupid. Okay, we don't want that. And now let's say we will have a count, x count 20, z count 15, and offset on the x-axis it was 1.5 by 500, but since we are dealing with 2 polygons, we take the double. Okay, and on the z axis the translational value is is we still have it on the clipboard, so paste it and multiply it by 2. Yes. So we have this hexagonal tiling or hexagonal tessellation, and of course if you want to do this mesh, you first model your basis, your base hexagon, and then you apply the same transformations. Or if you want to use instances, just make a copy of this, paste. If you want to use instances instead of mesh, you go to multiply, and here under more there is a make pole function which makes which will create for you pivots for every single cell. Ctrl C, go to layer 3, and we don't see, of course, because these are only points, so more, make 1 point polygons. Now we have a point grid. So if we check as background layer, the layer first layer, you see we have a point grid. It's very nice. So if you create any mesh within the boundaries of this hexagon, and you are on the safe side, and if you instance it, you will have the same layout as here. But instead of having a dense large mesh, you will have a lightweight, easy to handle, cool mesh. Okay. Yeah, and also this applies for other applications, so you can recreate this mesh in Blender or Houdini or whichever apps you favor. Okay, thanks for watching. Cheers and bye.